welcome back. We're on part 3 of our lecture now. Now that we have seen that there's these 4 types of winter precipitation, I want to talk about where they are found on a winter storm. Now, what I want to illustrate for you with this diagram that I'm going to be building down here is a cross-section of a warm front. Now, you might think, why are we looking at warm fronts if it's winter weather? But you can have precipitation along a warm front in the winter. I mean, if you're like in the cold side of the warm front, here, I'm going to draw it right here. That is a cross-section through my warm front. You can see there's a warm front at the surface. I've got a warm air mass and a cold air mass, the way we learned about, you know, back in like Module 5 or whatever. And this is a cross-section going from south on the left to north on the right. And I tried to illustrate that there with that color grading right there, where it's supposed to be like green and lush in the south and white and snowy in the north. Okay? So I have this cross-section here, and see how I have my warm air is rising as it goes over the warm front, as it overruns, to use the right word, the cold air mass underneath it. Okay? That is rising motion, formation of clouds, formation of droplets. This looks like a winter weather precipitation system. Why are we looking at it specifically along a warm front? That is a classic way to teach a class like Introduction to Meteorology, because there's a fairly straightforward pattern as to how the winter precipitation happens along a warm front. It's a little more complicated as to what's going on behind a cold front, for example. Well, so let's just focus about how we're going to get different kinds of winter precipitation as we have all of this lifting of gentle lifting of warm air as it goes over the cold air mass, as it overruns the cold air mass. Well, let's look at a couple of different locations along this cross-section through this warm front here. And so, like, if I was taking a location more or less right around the location of the warm front at the surface itself, well, lifting is producing precipitation that starts off, as all precipitation does, as ice crystals up high in the cloud. So I've got that X up there, and as those ice crystals are falling, they're falling through a warm air mass. As they are falling, they're going to be falling through a layer where it's thick enough they're going to be melting as they fall and change into rain. So I switch to the symbol of a dot. And all the way from there down to the ground, they're in the warm air mass. They're never going to encounter cold enough air again to refreeze that drop or anything like that. So any precipitation that's fairly near the warm front, in this case, was going to be falling in the form of rain. Now, let's try a different story here, though. What if we were way out to the north beyond the warm front? Where, like, now, again, we have lifting as warm air is overrunning as it goes over the cold air mass, and it's being gently lifted by the warm front here. And again, we're going to be forming precipitation in the form of those ice crystals. That's why I started off with an X, because we're way up high in the cloud where the temperatures are cold. And as those ice crystals are falling and falling and falling, long before they get to the ground, they're falling into the cold air mass. Well, from there on down, they're in a cold air mass that just came from the Arctic or Canada or something like that. They're never going to encounter temperatures anywhere near melting again, all the way to the ground. And so farther to the north, way far, a couple hundred kilometers north of the warm front, whatever precipitation here is falling is going to fall in the form of snow. What about, say, someplace between the two, but maybe a little closer to the warm front? So just a little north of the warm front at the surface? Well, let's see. We're going to start off with precipitation that is being formed as ice crystals up high in the cloud. That's why I started with that X. And as those ice crystals are falling, they're in the warm air mass. High above the ground, but in the warm air mass. So at some point, they're going to melt. That's why I switched, as they were falling, to those dots. And then as we get close to the ground, a little bit ahead of the warm front, you fall into the cold air mass. Okay, but that might only be a few tens of meters, or, you know, no more than maybe a couple hundred meters or something like that. That raindrop is going to fall through that in a matter of seconds. It will not have time to cool back down to freezing and start converting into ice. So that precipitation will reach the ground as a liquid, and then once it's on the ground and there's some time, it can freeze in that cold air mass. That's freezing rain. So we're going to be expecting to find freezing rain somewhat north of the area of rain along the warm front itself. Well, let's fill in with our 4th type of precipitation, our sleet. Sleet's going to be found between the freezing rain and the snow. Look again at that column there that I have that's pretty far north of the location of the warm front at the surface. And what you're going to see here is that we have ice crystals forming up high in the cloud. And as they fall, they're falling through the warm air mass, and they're probably going to melt. But then they fall into the cold air mass. And now we're far enough north of the warm front at the surface that here, they're falling through a pretty big chunk of cold air between there and the ground. That might be a kilometer thick at this point or something like that. There's plenty of time as they are falling through that cold air to at least make the outside of the raindrop freeze. And so they're going to hit at the ground in the form of sleet. Alright, I want you to see this pattern here. We have a pattern here where from south to north, as we would like if we were driving across a warm front, we would first be in the warm sector, and then we would encounter rain, and then as we crossed into the cold air mass across the warm front, we would first hit an area of freezing rain, and then an area of sleet, and then an area of snow. And that actually has interesting and important forecasting applications. I mean, if I just pull up a map of the Midwest here and put a pin on Omaha just to help you, with the geography here. If I was just thinking about where I wanted to have my winter precipitation associated with a warm front that, as I've drawn here, is associated with a mid-latitude cyclone and all that kind of stuff. Let's say my forecast was that I had this low pressure system, this cyclone, centered in like southwest Nebraska. And there's a cold front that goes down into Kansas and Oklahoma, all of which would have precipitation too, but it's more complicated along the cold front. I would expect to have some rain associated with the warm front itself, and then as we went farther to the north, we would encounter some freezing rain, and then an area of sleet, and then an area of snow. And these are in these bands that are parallel to the warm front itself, and they're kind of wide but narrow from north to south. So let's say that was my forecast. I thought the cyclone was going to be right there, and I'm going to put, okay, I think the snow is going to happen in this band. Oh, look, Omaha is in snow. All right, I'm going to forecast a certain amount of snow is going to form in Omaha. And let's say that, 24 hours later, the reality of what actually happens is my low was, well, that was actually a pretty good forecast. I mean, my low, instead of being in southwest Nebraska, it's a little bit farther north than that, closer to like North Platte. I am only off by a few tens of kilometers as to where I thought the cyclone would be, where I thought the warm front would be, and if I then look, oh my goodness, but that shifted these patterns of these snow and sleet and freezing rain, a few tens of kilometers to the north, and Omaha now isn't in the snow, it's in the freezing rain. Was that a good forecast or a bad forecast? Well, that kind of depends on who you ask. I mean, the public's going to be really mad at the meteorologist. You said it was going to be snow, and in fact, we didn't get any snow. It was all freezing rain. Yeah, it's just notoriously difficult to do these things because only a little bit off in terms of where you thought the warm front was going to be makes a big difference as to whether your precipitation is going to form in the fall in the form of snow or sleet or freezing rain or rain, and the public really wants to know. If you tell the public it's going to be rain, they make very different plans than if you tell them it's going to be 6 inches of snow. Okay, 6 inches of snow is only a ½ inch of rain. You tell the public it's going to be a ½ inch of rain, they don't care. You tell the public it's going to be 6 inches of snow and schools start to close. The difference is only a matter of a few tens of kilometers. This is why winter forecasts are often horribly wrong in terms of the type of precipitation that you get. Now that we know that nifty little trick, let's actually go on and answer a couple quick questions about the distribution of precipitation along a warm front before we go on to the next part of our lecture. Question 8. Suppose you were driving from north to south across a warm front in the winter. Put these forms of winter precipitation in the order, sorry, it says other, I should say order, you would probably experience them. And it's rain and snow and freezing rain and sleet. Then tell me what order they should be in as you drive from from north to south. Make a choice from those 4 options and get a little feedback before we move on to question 9.